All right, we're going to talk about proving lines parallel. The objectives are to recognize angle pairs that determine parallel lines and prove that lines are parallel. So this is doing basically the opposite of what we did in 3-2, where we identified whether angles were congruent or whether they were supplementary based on having parallel lines cut by a transversal. So now we're going to know whether angles are congruent or supplementary, and in knowing that, then we can determine that the given lines are parallel. So we're just going to quickly go through our postulates and theorems for this lesson. We have the converse of corresponding angles postulate, and you can see in the picture that lines A and B don't have the parallel line markers on there, and that's because we don't know that they're parallel yet. We're trying to determine that. It says if two lines are cut by a transversal so the corresponding angles are congruent, then the lines are parallel. So if we know, for instance, that that angle 1 and angle 3 are congruent, those are corresponding angles, and since the corresponding angles are congruent, then lines A and B are parallel. Then we jump down to our theorems. We have the alternate exterior angles converse theorem that says if alternate exterior angles are congruent, so in this case angle 1 and 3 are alternate exterior angles, if they are congruent, then lines P and Q are parallel. For 3-6, consecutive interior angles converse theorem, we have P and Q cut by a transversal. If 4 and 5 are congruent or supplementary because they're consecutive interior angles, then lines P and Q are parallel. So the measure of angle 4 plus the measure of angle 5 is equal to 180. Then P is parallel to Q. 3-7, we have alternate interior angles converse, and that says if two lines in a plane are cut by a transversal so that our alternate interior angles are congruent, so 8 and 6 are congruent, then P and Q are parallel. And the last one, one's a little bit different. This says the perpendicular transversal converse. So the perpendicular transversal, this would have said that if two lines are intersected by a transversal and create two perpendiculars, then P and Q are parallel. So the converse says if two lines are perpendicular to the same line, then they are parallel. And you can see that R is perpendicular to P and R is perpendicular to Q. Therefore, P and Q must be parallel to each other. At the top of this page, we just have basically the condensed form here, just a review of what we talked about on the previous page. If you can see that we all have these certain criteria, if the angles are congruent or supplementary, then the lines are parallel. And so in order to prove that lines are parallel, one of these 5 things has to happen. All right, so in example 1, it says if the measure of angle 1 is equal to the measure of angle 2, determine which lines, if any, are parallel. State the postulate or theorem that justifies the answer. So it tells us that the measure of angle 1 is equal to the measure of angle 2. So we know that for sure. So I'm going to identify that. And then we've got several lines going on here. So I'm going to look at, well, what lines create those two angles? Here's this one, these two. So M and R create angle 1, and M and S create angle 2. So what that tells me is that M is my transversal, and it's intersecting lines R and lines S. So R and S are the lines that are parallel. So I would say that R is parallel to S. And then how do I know that? Well, 1 and 2 are corresponding angles, so that's the converse of corresponding angles postulate. That one says that if corresponding angles are congruent, then the lines cut by the transversal are parallel. Example 2, it says find the measure of angle ABC so that M and N are parallel. So we know that the measure of angle ABC is represented by 6x minus 20. And in order for lines M and line N to be parallel, angles DAB and angles ABC would have to be congruent because those would be alternate interior angles, and we know if alternate interior angles are congruent, then the lines are parallel. That's the alternate interior angles converse theorem. So that means that the measure of angle let's back that up just a little bit. Angle DAB would have to be equal to the measure of angle ABC in order for our lines to be parallel. DAB is 3x plus 10, and ABC is 6x minus 20. And so we can solve for x. Then I'm going to subtract 3x from both sides. And that gives me 10 is equal to 3x minus 20. And then I'm going to add 20. And we get 30 equals 3x. So, and when I divide by 3, I get x equals 10. So we got x equals 10. We just don't have what the measure of angle ABC is. So we go back up to the top, and we're going to replace x with 10. We get 6 times 10 minus 20. So I get 40 degrees. So the measure of angle ABC is equal to 40 degrees. We cannot assume, so what we were doing there was we were saying what would have to happen in order for M and N to be parallel. And we know that we would have to have congruent alternate interior angles in this case for those lines to be parallel. And so, therefore, we made them congruent or equal to each other. In the next exercise, it says find x so that L and M are parallel. So just more of the same practice. We're just going to do a couple of these and then identify the postulate. So we want L to be parallel to M. For that to happen, we either have to have some congruent angles or some supplementary angles. In problem number 1, the angles that are represented here are alternate exterior angles, and we know that if alternate exterior angles are congruent, then L and M would have to be parallel. So I'm going to say that those guys are congruent to each other. That's the alternate exterior angles converse theorem. And that would make the two angles equal. So 5x minus 5 would have to equal 6x minus 20, and then we could solve for x. So if I subtract 5x from both sides, I'm going to have negative 5 equals x minus 20, and then I'm going to add 20, so x equals 15. And that's using alternate exterior converse. Let's look at number 2 because that one's a little bit different. So in this case, we have a couple of things. We have a right angle there. And so the right angle represented in the 3x plus 15, those are alternate interior angles. We could use that. We could also use the fact that if two lines are perpendicular to the same line, then they are parallel to each other. And so we can see that M is perpendicular to the transversal, so L would also have to be perpendicular to the transversal, which would make 3x plus 15, that would be a right angle as well. And so we would have 3x plus 15 equals 90. Would subtract 15, which would give me 75, and then divide by 3, x would be 25 degrees. And that is the perpendicular transversal converse. Okay, the next page has us doing a couple of proofs. These really aren't too bad. Again, we're proving that lines are parallel, so how do we know that lines are parallel? And it says you can prove that lines are parallel by using postulates and theorems about pairs of angles, which is exactly what we're going to do. So we have a little picture there, and it says given angle 1 is congruent to angle 2 and angle 1 is congruent to angle 3, and we want to prove that segment AB, and I'll just kind of highlight that there, is parallel to DC. Now I don't know that it's parallel yet, so I cannot use any of the theorems that say if something is parallel. These have to be converses because I am trying to show that they're parallel. In the first statement, it's showing our givens, so that's going to be our reason. And then it says, well, since angle 1 is congruent to angle 2 and angle 1 is congruent to angle 3, then angle 2 is congruent 3. That is substitution. And so it said that 2 is congruent to 3, and we can see that, okay, if I extend these out, okay, and imagine these being our lines here, then this is our transversal, and 2 and 3 are alternate interior angles. Well, we know that if alternate interior angles are congruent, then my lines are parallel, so that's the alternate interior angles converse theorem. Okay, and the next one, it says, again, complete the proof, and we have a picture and we have a couple of givens. We have that angle 1 is congruent to angle 5, so I'm going to just highlight those real quick. 1 and 5. And 15 and 5 are also congruent, and so I'm going to put that same marker there. We want to prove that L is parallel to M and that R is parallel to S. Again, we can't use any of the postulates or theorems that start with if two parallel lines are cut by a transversal, because we don't know that they're parallel yet. That's what we're trying to prove, so they have to be converses. We start with angle 15 is congruent to angle 5, that's a given. Then we have angle 13 is congruent to 15. How would I know that 13 is congruent to 15? Well, those two angles are vertical angles, so that's actually the vertical angles theorem. If vertical angles are congruent, the vertical angles theorem says if angles are vertical angles, then they are congruent, so we have that one. And then now we have that 5 is congruent to 13. And you can see that we actually have a connection there where a beginning of one and an end of another is the same. And so in that case, we can use the transitive property of congruence. All right, so I've got 5 and I've got 13. Well, if I look at 5 and 13, so here's angle 5, and here's angle 13, and I see that those two are, they have a common transversal of M, and so here's the lines that they go through to make that. Okay, so we're talking about R and S, and so if we're talking about lines R and S being parallel, 5 and 13 would be corresponding angles. So since the corresponding angles are congruent, lines R and S are parallel to each other. So that's the converse of corresponding angles. Okay, the next one should be pretty easy because the reason says that it's a given. And so the given we haven't used is angle 1 is congruent to angle 5. And so 1 and 5, we'll do another little highlight thing. Here's 1 and here's 5. So that's talking about lines L and M cut by transversal R. So we can say that L and M are parallel because 1 and 5 are congruent and 1 and 5 are corresponding angles. So now I can say that L is parallel to M, and they just wrote out the theorem, but it's the converse of corresponding angles. All right, guys, that's what I have for you. Honor students, there's your assignment, and I will see you during our next class period. Bye.